Okay. Let's see why dijkstra algorithm fails for negative weight. So I want to discuss few concepts here. So again I am recording it for first time. So please comment. Suppose there are four nodes A, B, C, and we have weights 1, 2, 100, and this is minus 500. So we have one negative weights here, and this is your source node, and I want to find a shortest path from S to all other nodes. Great. So by looking at the graph, we can see that the shortest path from S to B is 1, S to A is 100, and S to C is minus 400. So what was the golden rule for the algorithm? We have one set S, another set B minus S. Any node which is here, we can ensure that we know the shortest path for that node. Let's do this for this graph. Suppose we start from a source node S, then what we have to look at all the cut edges coming out of this particular component. So what are those? So how we calculate ds plus length of S comma A, d of S plus length of S comma B. So this is nothing but 100 and this is 1. So we will find the mean of this thing. So mean of this is 1. So we have new component. So in this component we can add a B to this thing. So initially it was S source node. Now we can add B. Fine. Now again we'll go and look up the other cut edges. So this is your one cut edge and this is another cut edge. So in second iteration I'll go and check d of S plus length of this edge, which is 100, and d of B plus length of this edge. What is this edge? B comma C. So this is nothing but 3. So minimum is 3. So we'll bring this thing C to the. So C was here, A was here in before the second iteration. So now C will be part of this component. So once C is here, we know the path of this C, shortest path, and we know the distance. So again in future iteration we will not compute for the shortest path here as per dijkstra algorithm. Great. So next iteration. So this is your new cut. Sorry. This is your new cut. So we have only one cut edge, this guy. So in next iteration I will go and look for only one node, that is node A, and we'll have this guy here. So finally A will be in this side. So what is the distance from S? No, written it down. S, A, B and C. 0, 100, 1 and 3. Each for the S for dijkstra algorithm. But we know that our correct distance for root node to node C is minus 400. So dijkstra algorithm fails here. Right? So this is one example where dijkstra algorithm fails. So you can consider other examples also. Okay, let me give you one more important idea before I discuss Bellman-Ford algorithm. What is this idea? The idea of negative cycle. So let me show you a cycle in a directed graph. This is a cycle. Okay, so let me put some weight 2, 3 and 5. So what is the weight of this cycle? 2 plus 3, 5 plus 5 is 10. So this cycle has a positive weight. Like if I add all these weights, see what you have to do? Pick a cycle, add all the edge weights. If it is positive, then we say it is positive cycle. Okay. Now if I change it to minus 7. So what is the weight of this cycle? 2 plus 3, 5 minus 7, which is minus 2. This is negative cycle now. Okay. So let me discuss a very important concept. If there is a negative cycle in a graph, then we don't have a definition of shortest path. Why is it so? So if there is a negative cycle, by negative cycle I mean you add all the edge weights of the cycle, and if it is negative, then we claim this is a negative cycle. So if there is a negative cycle, then there is no concept of shortest path. Look at here. Suppose this is a given graph, some graph, and if there is a negative cycle like this, between this node to this node, and there are many nodes here, and this all nodes are part of one cycle, and this is source node. If you start traversing from this, shortest path for this node is the weight of this node. For this node, you cannot say anything about this thing. Why? Suppose the weight is 5 and 6. The shortest path is 5 to this node, and to this node is 11. Correct. But if there is a negative cycle, so what you can do, from 11 you go and traverse some negative amount. You can keep on doing this thing, and finally you will get minus infinity for this. So if there is a negative cycle, you cannot, there is no concept of shortest path. You cannot define the shortest path for this node. Okay. So what Bell-Manford algorithm does, I will teach you the. If there is a negative cycle, it will report that there is a negative cycle. If there is no negative cycle, if negative edges are there but no cycle of negative length, then it will compute the shortest path. Okay, thank you.